Hi, my name is Patrick and I'm gonna show you how to create a physics-based sailboat controller in Unity. First of all, we need to consider how a sailboat works. And if you want, you can skip this part and go straight to the implementation, but I promise, I'll try to get through the theory in a nutshell. The main parts of the sailboat are the hull and a mast. Larger sailboats have more than one mast, however in this tutorial we will focus on single-mast sailboats. The force is generated on the sail and sets the yacht in motion. How? Aerodynamic force is created by the differential pressure created on the sail. On the windward side of the sail, the air molecules encounter an obstacle and crowd out, producing positive pressure, while on the other side the molecules have a longer path to travel, thus creating negative pressure. As you can see, the aerodynamics of a sail works similarly to an airplane wing. To calculate the force produced on the sail, we will use the following formula, where F is an aerodynamic force, C is coefficient of lift force depending on the angle of attack, ρ is density of the fluid, in this case air at the sea level, S is area of the sail, and V is speed relative to the wind called apparent wind. But what is the apparent wind? Let's imagine that we are sailing across a lake and there is no wind at the moment. When we increase the speed, we will feel the wind. The velocity of the apparent wind is the vector sum of the true wind plus the velocity of the headwind, which is the velocity of a moving object would experience in still air. Okay, that's enough theory, let's get started with practice. First of all, we need to add wind to our scene. So create a new game object named wind, and next create a new C# script. To simulate wind, we need the following float variables: the wind speed, the wind direction, maximum wind speed, minimum wind speed, frequency of speed changes, frequency of change of direction, variation of speed and variation of direction. Each variable is serialized for easier debugging from the editor window. The wind rarely blows all the time at the exactly same speed and from the same direction, so to add some randomness we will use coroutines. Let's start with the first one. Private E enumerator change wind direction, while true wind direction plus equals random.range minus wind direction change amplitude to wind direction change amplitude. Wind direction equals wind direction plus 360 modulo 360. Yield return, new wait for seconds, wind direction change ratio. We want to change the wind direction every time the function is executed by a value drawn from a range we specify. We also need to make our value range from 0 to 360. The situation is similar for the next coroutine. In this case, we need to check whether the wind speed value is less than max speed and greater than minimum speed. Finally, we add our coroutines to the start function so that they start executing when the scene is started. We will also add the public functions getWindSpeed and getWindDirection to our script. Now we come to the main part, which is yacht controller. For the purpose of the video, I created a model of a sailboat in Blender, but the most important things at this point are the hull, mast and sail. We will also need an additional game object we will call SailTarget, to which we will attach a simple script called follow position. Remember to make the sail a child of the mast. Now to begin with, we will create lots of variables such as wind, apparent wind speed, real wind direction, real wind speed, air density, real wind vector, apparent wind vector, rigid body, boat speed, sail area, sail transform and sail target. In start, let's assign values to rigid body and wind. Okay, to calculate the apparent wind, we need to make the conversion from degrees to radians. After adding a bit of trigonometric magic, we get a real wind vector. Then all we need is to subtract the boat speed vector from it, and congratulations, we have just calculated the apparent wind. Now apparent wind vector dot magnitude gives us the apparent wind speed. To calculate lift force, we need to find angle between our sail and apparent wind vector, after which we will calculate the lifting force produced on the sail. Remember to secure our simulation in case the wind is less than or equal to 0. The next step is to give the direction of our vector based on which side of the sail the wind is blowing from. At this point we can also check if we are in no sailing zone. In the update function, we will update the wind values, and in the fixed update, we will call our calculate scripts. Remember to put the physics scripts inside the fixed update. Assign values to variables, and now we can check if our script is working properly. As you can see, by changing the angle of attack, as well as the wind speed, the value of the lifting force changes. I hope this video helped you at least a little bit. Thank you for watching this episode. Leave a like, subscribe, and feel free to watch the next parts.